Here we are just at the Google homepage, and part of the challenge of getting into practicing for the pre-ACT 10 is just locating where these practice exams that are all computer-based exist. So we're going to just type in pre-ACT 10 practice test here, and you're going to get a couple of different options. And to be perfectly honest, if you just look at the other sections that we've provided explanations for this exam, you'll see that this Wisconsin Department of Public Instruction website, which is where we're going to access the exams, it's kind of moved around in the list. So you do have to go to this Wisconsin DPI website, and you're going to then click on Pre-ACT Secure Online Practice Test. Here, you do not need to log in. This login page is a little bit intimidating, but you don't have to sign in. You're going to go straight to practice tests. And once you're here, you can click on Pre-ACT 10 Secure Practice Test. For this video, we're going to be looking at the science section. And there are some options that you can select if you have specific accommodations, but here we're just going to click on the science timed button there. And you do have the opportunity to put in a name. Nothing is saved here because you didn't log in, as we just saw. So I just leave it as guest. We can hit start. We're going to click start to go to the main overview. You get some instructions just talking about how you can go through this endeavor. And if you haven't taken this practice section yet, you should do so before watching these explanations. And you can see you do have to write down your answers on a piece of paper to self-score the practice test because nothing is saved once you close out of the interface. So we're just going to click next, assuming that we've read those instructions. We're going to click next once more and submit. There are no questions there actually. Then we've got the science overview, which just provides us an overview of the science section and how that's going to work. You're going to click next one more time, and we're then going to submit, understanding that the next section is actually going to be the 35-minute and with 36 questions science section. So we will click start here. And as soon as you do, the timer begins. So you're going to want to go just straight to the first question. And do note that you are not allowed to use a calculator on this exam. So the key with the science section, as it was with the reading section and to a degree the English and math sections, is focusing on what you're being asked to do first. So here we can see, based on figure 2, on October 15, 2000, the O3 partial pressure was 0 for all altitudes in which of the following ranges. I'm going to highlight that, and I'm going to go straight to figure 2. And we see that in this figure, we've got O3 partial pressure, and we've got to go October 15th, which is going to be this dotted line on the left. And so the 0 is going to basically be happening from our altitudes here of about 19 kilometers to about 21 kilometers. So we'll select choice B and move on to the next question. Once again, we will read the question first. We didn't even read this whole thing up front. We're going to attack it all piecemeal. The question reads, based on figure 2, over the altitude range from 16 kilometers to 26 kilometers, what was the approximate maximum value of the O3 partial pressure on September 15th, 2000 and November 15th, 2000, respectively? So again, we go straight to figure 2. We're considering 16 kilometers to 26 kilometers, so we're talking about the whole thing. And I'm going to focus on September 15th, 2000 first, and I can see that's the solid line. So we're basically looking at, I don't know, it's going to be somewhere around this 4-ish point right here. And the approximate maximum value. Well, if we're looking at the maximum value, that's going to be about 7. So we can now use our answer eliminator and eliminate anything that does not have 7 for the 15th. And again, this can go pretty quickly. And we'll just confirm that for the November 15th date, we can see that there is a maximum of 20. Be careful, but you'll get B correct in quick order. Moving on to the next question. Based on figure 1, of the following altitudes, at which one did the air temperature vary least from October 15th to November 15th? So we've just got to look at this air temperature horizontal axis. We can see that everything is closest around this 25 kilometers mark. So we're just going to select D and move on to the next question. Here we're being asked, consider the information in the passage about the annual changes in O3 content in stratosphere above Antarctica. Based on this information and figure 2, on October 1st at an altitude of 18 kilometers above the location in Antarctica, the O3 partial pressure would have most likely been. So we're looking at an altitude of 18 kilometers going down here, and we're trying to go to October 1. So that's going to be between September 15 and October 15. So if we're talking about a altitude of 18 kilometers, we can kind of see that it's going down towards October 15th. I can probably get this without even looking at the information in the paragraph, just going, well, September 15th is here, October 15th is there, so we're going to the left in between those two dates at October 1, so it's got to be less than 4 MPa, as we can see with the metric there at the bottom. We'll click next at this point. So here we're being asked, consider the ultraviolet radiation that reached the location in Antarctica on September 15th, October 15th, and November 15th, 2000, after having passed through the stratosphere. Based on figure 2, on which of the 3 dates was the intensity of the radiation greatest? Well, I do probably need to read a little bit of the background information at this point. So in August, the ozone content of the stratosphere above Antarctica begins to decrease, reaching a minimum around October 15. Okay, so there's a big ozone hole that keeps it isolated from adjacent areas where the air has greater ozone content. In late October, the winds weaken, causing the ozone content of the air in the ozone hole to increase again as this air mixes with adjacent areas. So again, we can see that when we were talking about that atmosphere, the pressure of the ozone, it goes down to that dotted line and then it goes back up over November 15th. So intensity of the radiation, well, that's going to be when we have the hole. So we are not going to have the intensity of the radiation be greatest on any date except for October 15th. And the O3 partial pressure, now we just got to compare to figure 2. We know that it was least on that date. So our correct answer is C, and we'll move on to the next problem. And we've got our second little passage. So again, we're going to read the question first, not even going to engage the stuff on the left. So suppose student 2 had conducted a trial at which delta T2 was 0.19 S. We're looking for what the value of Y would have been in that trial. So we've got to go find student 2, and we go down to experiment 2, and student 2 has a table, and we really can rely on these tables pretty openly. So we're looking at T2 was going to be 1.91. Well, that would fit in between trial 12 and trial 13. And the Y value there was 50 and 75 respectively. So if we had a T2, a delta T2 that was between 0.145 and 0.217, well, then it would seemingly be between that Y value as well. So we select B and move on to the next question. Here we are being asked which of the objects listed below were used in both experiment 1 and experiment 2. So we'll highlight this and we'll just make sure that they show up in 1 first. So student 1 placed a horn. So we've got a horn in student 1. Let's go down to experiment 2 and see if we've got a horn. Oh, we've got a horn. So we'll highlight that as something that is definitely used in both experiments 1 and 2, so we can eliminate the answer choices with the answer eliminator that do not have 1 in them, and actually they all have 1 in them. Well, that's a little nuisance, isn't it? Now, experiment 2, when we're down here, we can see that there are 2 microphones in experiment 2. We go up to experiment 1, and we don't have a microphone here in experiment 1. So we know that a microphone is not in both experiments. We'll put that in our little red or pink, and now we can eliminate anything that has a microphone in it. So there go choices B and D. Then moving down to number 3, we've got a timing device. Well, a stopwatch would certainly be a timing device. And if we scroll down to experiment 2, we've got a timer. So a timer and a stopwatch are each a timing device. So we would select choice C at this point. Move on to the next question. Next, we've got a graph here, and we can see student 1 plotted delta T1 versus data versus X, and then graphed a line of best fit to the data as shown. So the gap shown near the bottom of the vertical axis suggests that even if the value of x had been 0, the value of delta t1 would not have been 0 as one might expect. Based on the description of experiment 1, this gap was most likely the result of. So we've got to think, why is there this gap in delta t1? And so we read the experiment. Student 1 placed a horn at a distant x in meters from a tall cliff, started a stopwatch when he heard the horn emit a sound pulse, and stopped the stopwatch when he heard an echo return from the cliff. He recorded this time interval delta t1 in s and then calculated sa using the equation described here. So why is delta t1 not starting at 0? Well, we've got to think about this logically, not by like way of anything truly scientific. He's starting the stopwatch and he's stopping the stopwatch. That start and stop actually takes time. So if we've got this in mind, we probably should be able to select D. But we have no reason to believe that the stopwatch is underestimating things. It's not the stopwatch that's making the measurements, it's the actual student. The echoes are not traveling faster. If anything, the echoes seem to be taking a little bit more time. And then the horn wasn't accidentally placed closer than intended, so we can eliminate those ones, obviously, and we've got our correct answer already of D. Moving on to the next question, we've got, in general, the farther a sound wave travels, the more it attenuates, making detection more difficult. In which experiment was attenuation of greater concern? So it reduces in volume. So we've got this short pulse, and we're looking at how it worked in terms of how it went back and forth. And between the two, we've got a shorter distance. If we're looking at table 2, we've got 50 meters to 100 meters. Up here, we've got much longer distances for student 1. And that would make sense that the sound would go down when it's got to travel a longer distance. So which one had attenuation of greater concern? Well, it's definitely experiment 1, and I should use my eliminator, not my selector. And it's because the sound waves had to travel a longer distance in 1 than in 2, so we will select choice B and move on to the next question. Here we've got, based on the results of both experiments, regardless of the apparatus or procedure used, on average, as a sound pulse's travel distance increased, the recorded time interval did what? So as we increase distance, what happened to the time? Well, here in table 1, distance increases, time increases. Experiment 2, distance increases, time increases. So it's going to increase only, and we're going to move on to the next question. Here we've got, in calculating the value of SA, student 1 needed a factor of 2 in the numerator. However, student 2 did not include this factor because of something, and we should have recognized already that the issue here is in figure 1, you've got to go from the horn to the cliff and back. In figure 2, we go from microphone 1 to microphone 2 and are testing just the microphones on either end. So student 1's experiment, the sound has to travel the same distance twice, whereas experiment 1 only had to do it once, so choice A matches that correctly. Again, hopefully if you could proactively identify this as the correct answer, you don't really even need to go into the other choices. Moving on to number 12, we've got our third little passage beginning, and it reads, based on table 1 and figure 1, across the 4 age categories, as the age of the helpers increased, the percent contribution to pup feeding blank. So remember, again, we are not going to engage with an upfront read here. We're going to go straight to table 1 and figure 1. So table 1, we've got the age categories, and we can see that it goes from juveniles to adults, and you can kind of follow this is just the ages, and it goes up. And then we're looking for the age of the helpers contribution to pup feeding. I can see that here in the second figure. And the juveniles, subadults, and yearlings, it keeps on going up. But then once you hit yearlings, it goes down a little bit. So it increased and then decreased for our correct answer of choice C, and we move on to the next question. Here we've got, when food is scarce, meerkats may lose weight, causing them to have a negative daily weight gain. Based on figure 2, if the percent contribution to babysitting by female helpers older than 1 year with a daily weight gain of negative 2 grams per hour had been calculated, it would have been most likely been where? So we're going to go straight to figure 2. And we've got daily weight gain, and we're looking at percent contribution to babysitting. So we know the weight gain was 0, 2, 4, 6, 8, 10. And we're looking at the female helpers, but we're saying if we went down, and that would be over here kind of to the left. Well, if we did that, the percent contribution, again, assuming that the line of best fit here is going to be consistent, would be below 15%. So that's going to match choice A, and we'll move on to the next question. Here we've got, based on table 1 and figure 1, the greatest difference between the percent contribution by male helpers and the percent contribution by female helpers was observed for which pup care activity and which helper age range. So hopefully we just know that juveniles are the lowest, subadults are going to be 6 to 12 months, yearlings are going to be 1 year old, and then adults are more than 2 years old. So I hopefully don't have to go back up to table 1 once I figure that out. But then when we go to figure 1, we want to find the biggest gap between female and male helpers, and we should be able to identify that as happening with babysitting almost immediately just because of the differences in the metrics. So we can eliminate the ones that involve pup feeding. And we've already established that the adults are going to be older than 2 years or 24 months. So we'll select choice B and move on to the next question. Here we have a student claim that for male helpers and also for female helpers, the percent contribution to pup feeding varies with daily weight gain. Okay, so we're going to just highlight that. Whoops, right there. And we want to know, is figure 2 consistent with this claim? So we've got to go down to figure 2 and see that contribution to pup feeding varies with daily weight gain. And so pup feeding is this bottom one. And I see that, yeah, it kind of is for the female helpers, but it's certainly not for the male helpers. So is this true for both male and female? We're going to have to say no, which allows us to eliminate the answer choices that say yes. And if we're looking at choices C and D, we should recognize that C correctly articulates that it's for the male helpers. The contribution did not vary with weight gain. So we'll select C and move on to the next question. Here we're being asked, the helpers whose contributions are recorded in figure 2 belong to which of the age categories listed in table 1? So again, we're going to go to figure 2. And so when we're looking at figure 2, we've got percent and female helpers, and actually we've just got nothing here. So if there's nothing here, we've got to go back up to our introductory statements. And we understand we've avoided these to this point. But now if there's information I can't find, I've got to assume, at least first, that it's going to be in the accompanying text. And we can see right here that figure 2 shows how the percent contribution to babysitting and pup feeding by helpers older than 1 year. And older than 1 year is going to be yearlings and adults. So not subadults and yearlings and adults. We'll select choice D and move on to the next question. Here we're being asked, S. suricata belong to which of the groups listed below? So once again, I've got to finally go into the introductory paragraph, and we're told that meerkats are S. suricata, and they live in groups of 2 to 30 individuals, and they are mammals. Some group members called helpers help parents care for their pups, and that's pretty much all we need. So I know that a mammal is an animal. So I know that it has to include item 1. A vertebrate, and this is kind of the very limited scientific knowledge you have to have for this exam. A vertebrate means that it has bones and a spine, and I hope you know that mammals do have bones and a spine, because we as mammals have bones and a spine. So we can now select 1 and 2 only, because you cannot be vertebrate and invertebrate at the same time either. So we'll move on to the next question, which is going to be another passage's start. And we can see we're being asked which of the following pieces of equipment was most likely used to collect the data presented in figure 1. So we're going to just go straight down again to figure 1, and we're being asked about mass. So mass, again, the limited kind of outside information you may need is going to be basically a requirement by weight. So a microscope is going to be about vision, so that's not going to help. A hydrometer is going to be measuring like the volume in water. Now a balance is a way to measure weight or mass, and a ruler is basically measuring length, so we should be able to select choice C at this point and move on to the next question. Here we're being asked which treatment resulted in the greatest average dry shoot biomass per plant for RP plants. So we've got RP plants, and I want to find the greatest average dry shoot biomass. So we've got average dry shoot, and then we've got average dry root down here. So we're looking for average dry shoot, and we can see that the greatest mass is indeed going to be the solid black treatment 4. We'll select that and move on to the next question. Here, we're being asked, the roots were washed after harvest, most likely to ensure something. So we've got to go find where they talk about washing the roots. And if we come down to the end of table 2, we see at the end of the 3-week treatments, the plants were harvested and their roots were washed, and then we're measuring the biomass. So we need to probably predict that we're washing the roots to make sure that we're not measuring the mass of the dirt on the roots. So we can get our eliminator here. We know it's not to guarantee that the roots could sprout afterwards. Intracellular water could be removed from the shoot biomass during the drying process. Well, no, it doesn't say anything about drying in the when we're washing. Washing happens before the drying, so that doesn't make any sense. Substrate particles attached to the roots were not included in the root biomass measurements. Well, ding, ding, ding. That's very technical, sciencey language, but that's absolutely correct. And then choice D, shoots were removed from the plants prior to the drying process. Well, that's just what happened. It's not what it was intended to do. So we can select choice C and move on to the next question. Here we're being asked, the plants investigated in the experiment were from how many different genuses? Again, the limited outside knowledge you might have to know for the pre-ACT science section. The genuses are going to be the first capitalized word of the species name. So we've got 2 achilleas, 2 festucas, and 2 rumixes for a total of 3 different genuses. And we'll move on to the next question, which asks, when the water level was maintained 2 centimeters above the substrate surface, which floodplain plants, the T species or the S species, had the greater average dry root biomass per plant? So we can see that there are different classifications. We've got AP as a T, FA as a T, RP as a T, and then the others are going to be S's. So if I can remember AP, FA, RP are all T's, that can help me. So now we're going to scroll down to where we find out that treatment 3 was about maintaining 2 centimeters above the substrate surface. So we've got to be focused on treatment 3. And we know that RP was one of our T species plants. And we know that RT was one of our S species plants. And it's basically structured that way for all of them. So that if we scroll back up, FA is a T and AP is a T. So FA is more than FR, AP is a little bit less than AM. So we've just got to find, and we know that T is going to be the bigger biomass, really just from the RP. So we can eliminate all of the answer choices that have the S as having the greater dry root. Oops, I got to scroll down and make sure I get the dry root structure here. But it's still the same. And so we're going to now make sure that all of the details are correct. So the T species plants, the average dry root mass per plant was greater for AP than for AM. No, it was not. So the average, actually it is, it's going to be real close, and greater for FA and greater for RP. So it's going to match that, even though the AP and the AM, it's a little bit off, but actually it's for the, I should have remembered that it's for treatment 3 anyway. We don't care about all of them. So it's going to be choice A. Just be careful and track the individual pieces. You'll get something like number 22 here, correct? Moving on to the next question, we're being asked, which of the following comparisons of the shoot biomass and the root biomass produced by S and T floodplains is best supported by the results regardless of the water level? And I already know all of this. The T is higher, right? So it's that the T has a higher root biomass. And so if we're shoot biomass, then root biomass, and that's the case for both of them. We can see that that's, and you can tell actually from the axis here on the left-hand side. So they're going to produce more shoot than root, and that's really all we need for that one. We'll move on to the next question, number 24, which is a new passage. We're being asked, the results of experiment 2 were recorded. The moisture content of the air was lowest in which tank? So we just got to go straight down to experiment 2. And if we're looking at experiment 2, the moisture content, I really don't know which is going to do moisture content. So I got to scroll back up, and we learn that the heat exchanger measures the RH and the aqueous tension. So the RH is 0.0 when there's a drying agent. So as RH goes up, you get more moisture content. So if we're looking at table 2, the RH being lowest in 7, at 7 for tank 1 will tell us that tank 1 has the lowest moisture content. We'll move on to the next question. Then we've got another salt, KCl, had been tested in experiment 3, and that the RH recorded was 81%. We've got to determine what the aqueous tension would be, going straight to experiment 3. So if the KCl was 81%, well, that's going to be between NaCl and K2SO4, so it's got to be between 110 and 140. We'll select choice C and move on immediately. Here we've got a student predicted that for a given salt in experiments 1 through 3, RH would always decrease as temperature increased. This prediction was consistent with the results for which of the salts listed. So we've got to show that RH down as temperature goes up. So we've got the temperature changing in each of these. So we start with a constant of 10 centimeter or centigrade or Celsius, depending on where you are in the world. And then we see that experiment 2 goes to 30, and then experiment 3 goes to 60. So it should show that it goes up from 1 through 3. So I'm going to just focus on the salts listed. So MgCl starts at 34, and then it's 33, and then it's 30. So yes, it's very limited, but it does go down for MgCl2. Then we go to MgNO32. We've got RH at 57 at the lowest temperature. Then it goes down at 52, and then it goes down even further for 43. So number 2 certainly works as well. And then if we're being efficient, we'd probably just pick choice B at this point, but just to prove the NaCl doesn't, well, it goes 76, then 75, and then stays at 75. So that's pretty constant. Our correct answer is going to be B. We move on to the next question. Here we've got a student predicted that under any of the conditions used in experiments 1 through 3, if the RH in any 2 tanks was the same, then the aqueous tensions of the salt mixtures in the tanks should be the same as well. We're going to look at the experiments 2 and 3. So looking at 2 and 3 only, and we've got to show that the RH is the same for 2 different salts. So it's not the same for KOH, but it is the same for K2SO4. But the aqueous tension is not the same at all. So we've definitely got a big gap there. And then if we're looking at another 75, again, it's a big difference between NaCl at 24 versus 110. So if we're looking at our correct answer, we can eliminate the yeses. The RH in tank 2 in experiment 2 was equal to the RH in tank 3. Well, no. But the RH in tank 5 was equal to the RH in tank 5 in experiment 3, and the aqueous tensions were different. Absolutely. So our correct answer is D. We move on to the next problem. So what was the purpose of the first procedure that was carried out on day 1? We might actually remember this, and it's that they put a dish containing a salt mixture, and they put a drying agent in the tank. So we want to get rid of all of the water so that our measurements are correct. Our correct answer is going to be A, and we're going to move on to the next problem. Here we've got in experiments 1 through 3, was RH an independent or dependent variable? Well, the RH is changing based on the temperature. So it is not independent because it's not set independently of the experiment. It is not a factor directly established by the chemists. It is a factor that was measured by the chemists. So our correct answer is D. We move on to the next problem. And we've got our next passage about modern birds. So we're being asked about what both scientists would agree about modern birds. So this is the only time I may have to do a little bit of an upfront read. So we're talking about 3 animal groups: crocodiles, non-avian dinosaurs, and modern birds. And we've got some details about their rates. And so scientist one says that modern birds inherited these traits from non-avian dinosaurs. And so that's what's happened. And we can see there's this evolution thing. And then if we keep moving, we've got modern birds from scientists two have evolved from non-avian dinosaurs. Don't get bogged down in the details, but we can select choice B, hopefully at this point, understanding we just need to read enough to find what they're going to agree about. Then we've got scientist one characterized the animals in which of the three groups as poikilothermic. I think that's how we pronounce that, but I'm not entirely sure. But I've got to focus on that, and I'm going to get this poikilothermic immediately highlighted. So the scientists characterized the animals in each group by their resting metabolic rate, RMR, and according to whether they were poikilothermic, which means that they had body temperatures that varied significantly, or homeothermic, had body temperatures that remained relatively constant. And we should recognize that the varying significantly means it's going to be cold-blooded, whereas warm-blooded is how you stay relatively constant, because cold-blooded you are influenced by the exterior conditions of the environment. So again, the limited outside knowledge you might need to have. So looking just at one, we know that crocodiles and non-avian dinosaurs evolved from common ancestor that had low RMR and were poikilothermic. Actually, we don't even really need that much, do we? Because now we know it's crocodiles and non-avian dinosaurs. Well, actually, we got to be careful. Crocodiles retain these traits. So we know crocodiles have to be included, so we can eliminate choices D and B. Then we learned that the non-avian dinosaurs became homeothermic, so we can't choose C actually. So read carefully, and our correct answer is indeed A. We move on to the next problem. We've got would scientist 2 more likely expect to find bones that have growth rings in a crocodile or in a modern bird? So we're going to come down here and we're going to look for bones with growth rings. And we know the bones of non-avian dinosaurs were dense and had growth rings. Okay, so non-avian dinosaurs. And we recall that modern birds evolved from non-avian dinosaurs. So it seems like maybe that's the case. And then neither is seen in the bones of modern birds. Oh, okay. So it's just the non-avian dinosaurs. And so if it's not modern birds, it has to be a crocodile. So we can eliminate choices C and D. And crocodile scientists too suggested that growth rings indicate a high low MR. Well, no, or a high RMR. No, it's indicative of a low RMR. So that matches the crocodiles. And our correct answer is B. Moving on to the next question. And you just saw there's a little 5-minute timer that clicks up. You can just close it out and really don't pay too much attention to it. Then, in which of the three animal groups would scientist one most likely expect to find animals having bones with extensive vascularization? So we've got extensive vascularization is seen in modern birds, so we can eliminate answer choices that do not have modern birds. And we know that non-avian dinosaurs also had this extensive vascularization, so that's going to allow us to change back to our pointer and select choice D. We move on to the next question, and even though you probably feel like you're pressed for time, you got to be going at about a minute per question. So with three questions left in about 4 minutes, we're in fine shape. So here, consider a rock formation containing many bones and nesting sites from non-avian dinosaurs, as well as indicators of a stable but cold climate. Okay, so we've got bones and nesting sites from non-avian, and it's cold. Suppose it were discovered that both the non-avian dinosaur fossils and climate indicators have been present together throughout the entire 50 million year history of the formation. This discovery would support the viewpoint of which scientist, if either? So, okay. So we know that it's got to be cold, and we know that according to scientist one, non-avian dinosaurs were homeothermic and could have survived in cold climates. So that certainly supports scientist one. So goodbye neither, and goodbye scientist two only. So now we've got to go down to scientist one. So here at the end of scientist two, non-avian dinosaurs were poikilothermic and could not have survived in cold climates. So it does not support scientist two. So we can select our correct answer of choice A and move on to the next problem. Here we've here we're asked, suppose it were confirmed that the common ancestor of non-avian dinosaurs and crocodiles had a low RMR. This finding would be consistent with which of the scientists, if either. So again, we're going to just focus on the common ancestor of scientist one. So, or of the non-avian dinosaurs and crocodiles, according to scientist one. So we're going to just highlight that sentence, and we see that it was a low RMR. Okay, so that's going to match scientist one, so we can eliminate choice B and choice D because we've got a common ancestor. It has a low RMR. So now we've just got to consider scientist two. It says crocodiles and non-avian dinosaurs evolved from a common ancestor that had a low RMR. So again, this is consistent with scientist 2. We can select choice C and move on to our final question, which is asking us to consider a crocodile and a modern bird each having the same body mass. Based on scientist 2's discussion, which animal would more likely produce CO2 at a faster rate, the crocodile or a modern bird? So again, this is going to require a little bit of outside knowledge. And we know the animal is using caloric energy when at rest for RMR. And that's when you produce CO2 basically as you breathe. So, or as the animal breathes. So the crocodiles have a low RMR. So they are not going to produce this that fast, which means that it has to be a modern bird that's going to have a higher RMR. And I guess I should have been in scientist too, but it doesn't really matter because either of them say that we've got a high RMR for modern birds as opposed to the crocodiles, which had a low RMR. So it has to be the modern birds that have a high RMR, which matches choice C. When we click next, if you have any time left, you can go back to the questions to seek them out, but you're going to want to submit your final answers so that you can see it before the time expires. And if you have any questions that you'd like to go back and review, do recognize that there are no explanations, but you can kind of do that before you close out of the interface. If you do close out of the interface, make sure you write down your answers, and you can do that again going back to the review screen here and selecting the individual questions. And then you can go back to them because the test does not change from one administration to the next. But hopefully, by working through this practice exam on your own and then seeing these explanations, you're able to better understand how you get to the right answers on the pre-ACT, or really the actual ACT science section. As you can see now, our time has expired and we'd have to go back to our self-recorded answers to review things further.